Okay, we're looking at 2.5, reasoning with properties of algebra. So this is to start to get you in the mindset of our proof. And we're going to use algebra first to show how a proof works before we do it with geometry stuff. Algebraic properties of equality. Let A, B, and C be real numbers. Addition property. If A equals B, then A plus C equals B plus C. If subtraction, if A equals B, then A minus C equals B minus C. Multiplication, if A equals B, then A times C equals B times C. If division, A equals B, then A divided by C equals B divided by C. Reflexive, A equals A. Symmetric, A equals B, then B equals A. Transitive, if A equals B and B equals C, then A equals C. Substitution, if A equals B, then A can be substituted for B in any equation or expression. Those last ones, reflexive, symmetric, transitive, and substitution, you're going to see a lot. You might want to write them down in your theorem and postulate sheets. Those last four. Okay. All right, let's look here at example 1. We've got 10 minus 2x equals 3 times x minus 2 plus 4. Okay. My first step is going to be distribute. So I get 10 minus 2x equals 3x minus 6 plus 4. But I have to put the word next to it, distribute. Okay. Next, I'm going to combine like terms. And say combine like terms. Okay. Next thing, I'm going to get all the x's on one side. So I'm going to add 2x. And I say combine, what did I say? X is on the one side. Okay. Now I'm going to add 2 to both sides. We call this addition. And then we're going to divide. So 5 goes into 12, 2 times with 2 fifths left over. Okay, so this is where we get that idea from a proof from. I did all my math on one side, but the other side was all my reasons. We're not going to do the other one because I think you guys kind of get it. B. We're not going to do B. Right? Because you know, you would get all the x's on one side would be your first step. Dividing would be your second step.
How do you get all the x's on one side?
By subtracting or adding and moving it across the equal sign.
So we don't.
So you would subtract 2x from each side.
So this way you're just supposed to say.
You're solving it, but you're saying how you're solving it.
Okay.
So solve it too.
It is kind of weird because you're like, why? I know what the steps are. Why am I writing them all down? But when it's geometry, it won't be as obvious. And some of it will be as obvious, and it'll be annoying. But you have to state all your steps. You guys watch those. You've at least seen like a Law and Order show or one of those law shows.
Yeah.
Okay, so a lawyer doesn't say, this is what happened. He says, this is what happened, and this is how I can prove it. I can prove it by saying, this person saw it, or by this piece of evidence. Okay, so that's kind of what geometry is. It's kind of like the lawyer. You have to prove something by using evidence. And your evidence in this case is your postulates and theorems. Okay, so we're going to look at example 2a. In the diagram, we know that WY W to Y is equal to X to Z. We want to show that WX needs to be equal to YZ. Okay? So first I'm going to write down this. I am given, okay, that WY equals XZ. Okay? WY equals XZ. Then I'm going to say that WX plus XY equals WY. And what is that called? Segment addition. Good. I'm also going to say that XY plus YZ equals XZ. And that's also segment addition, so it's just the same thing. When I write those little quotation marks, it means same as above. Okay. So now I'm going to use this thing called substitution, which we've talked about. I'm going to say WX plus XY equals XY plus YZ. And we call that substitution. Since I know these two are equal to each other, I know that their additions are equal to each other.
We are experiencing some difficulties with the system right now. As soon as we find out more information, we will let you know if it's up and running again.
Okay, so now what I'm going to do is I'm going to subtract. I'm going to subtract XY from both sides, and I'm left with WX equals YZ. So that's your look at your first proof. This little subtractor. Oh, please. Subtract.
There's no E in subtract.
I really want there to be an E at the end. Okay, no E.
Spelled the same thing.
Okay,
Hold on, wait, I have a question.
yes.
What is the process for?
Because I subtracted them from both sides, and so they disappeared. Right? So I went minus XY minus XY. So they're gone. Is that better? There should be. That's just my poor handwriting. Okay, so this, you'll have to do some of these on quizzes coming up. Okay, you'll have to step-by-step proofs. So instead of doing another proof just like this for the second one, what I think we should do is talk about what properties we think we'll use instead of going through the proof. Because a lot of people get confused with proofs because they don't know what comes next or what property they should be using. So let's look at this equation right here. We're talking about that AB is equal to DE. AB equals DE. I know that BC equals CD. It's a bad, if you want to copy this down from here, I think it got cut off on yours. And then we want to prove that A to D equals B to E. So let's list some of the properties that you think you'd use to prove this. Yes?
Segment addition.
Segment addition for sure, maybe multiple times.
Subtract.
We're going to have to use some subtraction, yeah? Let's spell it right this time.
What's given?
Okay. What else?
What's given?
You're going to have to use given. Yeah, you're going to have to use the given for sure.
Substitution.
You're going to have to use substitution. So if you're having trouble with proofs, the first thing you should probably do is write down all the things you know. Okay, that's the given. Then you might want to list things that you might have to use. Let's turn it over on the back and we'll try another one.
Wait.
Yes.
So we don't solve it?
For that one, you should solve it, but what I'm doing is just listing all the things. So I'm trying to explain to you what is going on in my brain when I make a proof. Because a lot of you are like, yeah, Ms. Murphy, your proofs make perfect sense, but how did you come up with that? So I'm saying one of the things I do is I write down all the stuff I know, and then I write all the stuff that I might use. So I know I'm probably going to use segment addition. I know I'm probably going to use subtraction and substitution. And of course, I'll have to use the stuff I know, the given. S-U-B-S-T. Sorry, just winding up. S-T-I-T-U-T-I-O-N. Sorry about misspelling. All right. We all have our strengths. Can you believe I double majored in English in college? There's this great thing called computers and they spell check for you. And I never had to handwrite anything. Okay. So we're on the back and we're given that AQB is equal to CQB. So AQB, so this angle right here, do you see how I draw all over it before we move on? You got to do that or else it's not going to make sense. Is equal to CQD. So this angle here. And what I want to prove is that AQC, this angle right here, is equal to BQD, this whole angle right here. Okay. Before I make my proof, let's talk about this. What do you think we're going to use? We're going to use given. So I'm just going to make a little list over here, just so we're thinking in our head. I'm going to use the given, and that's angle AQB is congruent to angle CQD. What else am I going to use? Angle addition. Probably substitution. You guys just want me to spell this again. Alright. What else do you think we're going to use? Maybe some subtraction? Okay. So what do you think we should start with? What's the first thing when we're making our proof we should always start with? Given. Okay. So I'm going to put the reasons over here this time, and I'm going to put the math stuff over here. So first I'm going to write given, and then I'm given this. Angle AQB is congruent to angle CQD. Yes?
Did you say you were going to put math on that side?
That's what we did for the last one, but I'm switching it because you'll see more that look like this.
So.
Oh.
Reason. Yeah.
Reasons. Wow. I had dyslexia today. Okay. Do this. What should come next? Probably angle addition. So this is how I'm going to do the angle addition. So I'm going to write angle addition, Pasha. I'm going to say angle AQB plus angle BQC equals angle AQC. And then I'm going to do another angle addition, but I'm going to put angle CQD plus angle CQB equals angle BQD. Slow down?
Yeah. Can you say what you said before
Yeah.
you said?
Okay, I'm going to